Second video on solving simultaneous equations. Previous one we looked at graphical method and substitution. I'm now going to look at my favourite one, elimination. So elimination is when we've just got, by and large, linear equations. So this would be an example that we could do elimination on. I've got x here and y here, x here and y here. What I need to do is to get the same number of x's or the same number of y's in both these equations. So at the moment I've got 2 and 3x, 3y and 1y. Easy way to do that is to multiply the bottom one by 3. Now, when we've got the same number of x's or y's, what I do is I add up or I take the equations away from each other. We look at the term that's got the same number, so we're looking at y, 3y and 3y. If the signs are different, a plus and a minus, I add the equations up. If the signs are the same, so 2 pluses or 2 minuses, I then take them away. There will be an example of taking away in a minute. This one, the signs are different, so I add them up. 2x plus 9x is 11x. 3y add on minus 3y is nothing, and that's the whole point of putting the equation together. I get rid of one of those letters, I eliminate it, and then 9 plus 24 is 33. So what I get is 11x is equal to 33. Always a good sign in the exam when you've got one that you know is going to divide reasonably easily. 33 divided by 11, I find out that x is 3. Once you know that x is 3, you put that value back into one of these equations. Put it in the one that you think is going to be easier. I've chosen the one at the top, just because I often do 2 times 3 is 6. 6 add 3 lots of something is 9. So that 3 lots of something, y must be 1. Okay, so that's the elimination method. These are the sort of questions you'd get. As you can see, you're going to use elimination on these because they're all linear equations. A harder example you might get is where you don't just multiply one of the equations by a number, you've got to multiply both of them by something to get the same number. We look here, there's not just one number I can multiply one of these equations by. I have to multiply the top one by 2 to give me 6y, and I do the bottom one by 3 to also give me 6y. I could have done the top one by 3 to give me 6x, and the bottom one by 2 to give me 6x as well. Would just mean that you'd find out the value of y first of all. Now I've multiplied them to get rid of the value of y. Again, if you look at these signs, the signs are different, so I add the equations up. 4 and 9 give me 13x, 24 and 15 give me 39. Another good sign, that divides quite nicely. Again, x is 3. When you knew what x was, you'd put it back into one of these equations to solve it. Hopefully I'll have time on this video to show you a live example of me actually writing it out. I know you love them. Just like Blue Peter in the old days, here's one I prepared earlier. If you look at these two equations from question E, I've decided to multiply the top one by 2, so I get 6y in both the equations. So here's my new equations. 10x plus 6y equals 34, comes from doubling 5x, 3y, 17, and the bottom one has stayed the same. So I've got 6y in both of these. Now in this one, we see the signs with that y that's got the same coefficient are the same. So when the signs are the same, that's when I take them away. If they're both negatives, or both positives, both signs are the same, we take away. So when I take away 10x, take away 1x, we'll leave me with 9. 6y, take away 6y, leaves me with nothing. That's the whole point of doing this elimination. We get rid of one of the letters. And then 34, take away minus 2, in fact 34, add 2, which gives me 36. Another nice sign that I'm getting a tidy division, 36 divided by 9, which come from there, the opposite of times by 9 divided by 9, gives me that x is 4. Now I know that x is 4, I just put it into one of these equations at the top. You can choose which one you think is going to be easier. I chose to do it in this one to avoid me having to mess around with negatives over here. So 5 lots of 4 is 20. 20 add on 3 lots of something is 17. Well, that's actually then telling me that this something here that I'm adding on must be take away 3. So 3y is equal to minus 3. Therefore, y is equal to minus 1. If you have time in the exam and you want to be really thorough, you can put the two values you've worked out back into the original equations. So we worked it out from this one, and I put the 4 in there to work out that y was minus 1. So I'm now going to put it into this one to double check that I've got it correct. So I know that x is 4. I know that y is minus 1. So 6 lots of minus 1 is actually minus 6. So I'm doing 4 add on minus 6, which does give me minus 2. That gives me confidence I got those marks. Probably 3 or 4 marks in the exam. So well done. Okay, moving on to a star question now. Difficult thing here is just the numbers are more difficult because you're dealing with fractions. I've written out the answer for A for you. And again, I'll see if there's time to do a live video one. I've decided again to get rid of y, just because it seemed easier to me, and to do that I multiplied the top equation by 4, because y divided by 4 times by 4 gets me y, which is the same value as I have at the bottom here. So I've now got, in my next up equations, once I've multiplied the top one by 4, 4x divided by 3 minus y equals 6, because 3 over 2 divided by 4 is 6. And the bottom it stays the same, 2x plus y equals 14. Y's is where they've got the same coefficient, different signs in front of those y's. So what do? Add them up. If the signs are the same, I would take away. For this one, I'm doing the adding up. So 4x divided by 3, add on 2x. But if you think about what this would be if it was over 3, it'd actually be 6x over 3. So in total I've got 4 and 6, I've got 10x over 3. This is why these are trickier, it's just a bit of arithmetic you need to do. Again, y, or that minus y, to be clear, add on y will give me nothing. So I've got rid of my y's, I've eliminated them. 6 and 14 is 20. So when I put this all through there, I've got to divide this side by 10 over 3. So I've got to divide this side by 10 over 3 to find what x is. X comes out to be 6. And I know that x is 6, put in one of these. Maybe easier to put in this one, which I haven't got to mess around with so many fractions. 2 to 6 is 12, add on something is 14, so y is 2. So I'm going to work through G from question 2. I have written the first line out just so it doesn't take forever. But the first thing is, if you look at these equations, I've got m and n on different sides. So I've swapped this around and I've brought that minus 5n over to here to make it plus 5n. So it now looks like I'm looking at this equation here. Sometimes people like to number them. Equation 1, equation 2, just to keep a track. And I can now look at what I want to get the same. I'm going to double this bottom one. So I'm going to end up with 2m plus 10n equals 28. Now if I look at these equations, I've got 2m and 2m. They're both positive. The signs are the same, so I'm going to take away. You might naturally think you do this one, take away this one, because that's the way a subtraction sum's set out. But you can just think about, I'm going to do equation 3, take away equation 1. So I'm going to do 2 take away 2, because the signs are both positive, signs are the same, so I take away 2 gives me nothing. And then I'm doing 10 take away 3 to leave me plus 7n,
and then I'm doing 28 take away 14 to give me 14. Okay, that just gives me tidier positive numbers to work forward with. Now I know that 7n is 14, reasonably easy to work out that n is 14 divided by 7, which is 2. And again, I'm now going to put that back into one of the original equations. I know that n is 2, so if I go back under here, I'm going to put it in this one, because again, I've got less negatives to work with. So 2 lots of something, add on 6, because 3 lots of 2 is 6, gives me 14. So there's 2 lots of something, must be 8, therefore that tells me that m is 4. Next bit you can do if you want to be thorough again, is you can use those 2 numbers in this one. We said that m was 4 and n was 2. So is 4 equal to 14 take away 5 lots of 2, 14 take away 10, yes, that does work. So I've double checked it, I've done it right. So this is D out of 7, lots of fractions, and I'm afraid it's got S, and sometimes my S's look like 5s, but hopefully you'll keep track. I've got to decide what I'm going to make the same. I looked at this and decided to make my T's the same. I'm going to get 1T in both of them. So I'm going to do the top one multiplied by 4, because T divided by 4 times by 4 will give me 1T. And I'm going to do the bottom one multiplied by 10, because T divided by 10 multiplied by 10 will give me T. So I'll have T in both of them. Multiply the whole of the top one through by 4, I end up with 20s over 6 plus that T, and then that's going to be equal to 32. Bottom one multiplying through by 10, so I get 20s over 5 this time. Got the T there, and then on the bottom I'm going to have 40. Okay, signs are the same. Where I've got these coefficients the same, the signs are the same, so I'm going to take these equations away. Again, I'm going to do the bottom one, take away the top one. Just remember to be consistent there and doing this, take away this. To take these away, I'm going to need, like any fraction, to have them over the same denominator. So I'm going to need them both over 30, because 5 and 6 go into 30. So this will become 100 over 30s, because I've multiplied the top and bottom by 5. This one will become 120 over 30s, because I've multiplied the top and bottom by 6. I've still got 2 T's there, 32 and 40. Can now do that takeaway. 40 take away 32 is 8. 120 over 30s take away 100 over 30s, just easy with 20 over 30s, and I've done T take away T to get rid of it. That's the whole point, I've eliminated it. So I've got 20 over 30s is equal to 8. That simplifies reasonably okay down to 2/3 s is equal to 8. So s is equal to 8 divided by 2/3, because that's the opposite of times by 2/3 on that side. So, excuse me, that looks like a 5. Now remember from Murph Maths, when you divide by a fraction, you can flip it over and then multiply. So I'm going to do 8 times 3 over 2. 8 divided by 2 is 4. 4 times 3 is going to give me 12. Then I can put that 12 back in the original equation and find out what T is. My goodness. But it was just about following the same steps and being careful. Good luck with that. Take care. Bye bye.